Hi! I want to show you an intonation that I have discovered. Mathematically it consists of perfect fifths and what I would want to call perfect tritones. This intonation could be useful, for example, for creating one-bit music, and I'll soon show you why. You can try my instrument with the tuning on your cell phone at cu.at/diamond. That's cyu.at/diamond. And as you might know, a perfect fifth is created by taking a frequency, multiplying it by 3 and dividing it by 2. The integer 3 is part of the harmonic overtone series, and to return to the initial octave, one divides the overtone by 2. The tritone that I use also makes a lot of sense mathematically. I use the square root of 2 times the initial frequency, because adding 2 tritones of that kind will get us exactly to the same note 1 octave up. This is helpful for us not having to make new notes infinitely. In other words, we're actually dealing with a Pythagorean tuning because of the fifths, but with 2 bass frequencies, a tritone away from each other. There's no wolf note anymore, and that's great, but there's actually 14 notes instead of 12. Is it possible to erase 2 of them to create a 12-note system? Yes. Would it harm the perfectness of 2 of the fifths? Yes. We're not changing laws of mathematics here, but those 2 fifths will not be much off at all. Now, let's experiment a bit. Let's distort the sine waves that come out of the instrument, and then we'll compare them to the normal tempered tuning that we are used to. Here we go. Yeah, now that was a few of the perfect fifths there now. Let's listen to the tempered tuning, how they sound there. Yeah, in our normal tempered tuning they will wobble a bit. But let's listen to some other intervals. This is now my intonation. Yeah, and this is tempered intonation. In sound engineering, we talk about something called intermodulation distortion, and that's when 2 frequencies make a new frequency. So, in our case, the new frequency will be down under our fundamental frequency. But we can also see that the new frequency we get will be harmonically more in tune than the one we get from the tempered tuning. Let's have a listen. My intonation. And tempered intonation. Mine. And tempered. My. And tempered. Like I said, when we're creating one-bit music, this might be very useful because the only thing we have to access is full distortion then. So that's when we want to have all the frequencies in tune. I hope you found this useful at all, or maybe you want to take it a try, or maybe you just think that I'm kind of stupid. Have a great day, and I wish you the best. Thank you very much. I'm Roger Ojala.